So remember, properties are going to be huge this unit. Okay, so if you have those on your study sheet, like what am I talking about? Page 190 in your books, right? Those, I give you the quadrilaterals and all of that, right? All of those different shapes that we have. So that's going to be huge on the test. Looking at his chocolate bar from the top view, Brian states that it looks like a rectangle. State two properties of Brian's chocolate bar that make it a rectangle. There's a lot of options you have there. You could say that there are two pairs of congruent sides, for example, right? Because if you think of a rectangle, right, we know that these two are the same and these two are the same. So two pairs of congruent sides, that would be one. You could write down 4 right angles. I would accept that. I would also accept the fact that the diagonals are actually the same length. So diagonals are congruent. Right? Are congruent. You could say that the diagonals bisect each other. That's also all right. 2 pairs of parallel sides, right? This side is parallel to that one. This one is parallel to that one, right? They never intersect. So anything like that, 2 marks for that, okay? 1 for each. And second one, name the following triangles. And so if you go by side length, these are the same, so that makes it an isosceles, right? And if you look at the shape of this, they all look acute, less than 90, right? So this would be an acute isosceles. Right, 1 and 1, by the way. 1 for acute, 1 for isosceles. We'll change this where this 2 is there. Scratch that. It's going to be out of 4. Right, next to question 2. And then the second one here, you can clearly tell that this is bigger than 90, right? So it's an obtuse scalene. Because all three sides are different, so 1 and 1. Order doesn't matter. So if you've stated it the other way, no problem. Okay. Next, sketch a rhombus and label all congruent parts. I would say at least 2 things about it. That's what I would actually have wanted you to do, but let's see here. If it's all congruent parts, if this is one of the diagrams, that would be that the sides are all the same. This angle is equal to that angle, and this angle is equal to this angle. If you have something like that, you get 2 marks. Another one you could have drawn with all the things that are equal, right? These are all the same. You could have drawn your diagonals like this, and you know that this chunk is going to be the same as that, right? Like, and this one is the same as this one. The diagonals bisect, right? But I would say any 2 properties that you identified, I would give you 2 marks for it. Okay. Next, a kite is a type of polygon. State 2 properties of this polygon. So I'm just thinking here, right? If you have this on your study sheet and you just have the markings on it, that would be like a pretty good diagram on your study sheet for a kite. And then you just read it to me, right? You would say 2 pairs of congruent sides, for example, right? 2 pairs, there's 1 pair here, 1 pair there. The other properties that the diagonals meet at 90 degrees, or they're perpendicular, right? If you want the perpendicular, right, or the symbol for perpendicular is like that, you could say that the shorter diagonal is bisected. You could say that there's 1 pair of congruent angles. you should be able to just look at it and know that all of those things are true, right? You know what? The sum of interior angles is 360, could also be 1. If you add up all 4 angles, it's 360 degrees, right? So this page is out of 2, 4, 6. This one is out of 10, this page. So put down a mark out of 10 on this one. And then let's go to the next page. Martha is building a triangular ramp over a drainage pipe. She's considering the following designs, right? You have your right triangle, right? You have this one and that one. What type of triangular ramp would allow the wheelbarrow to be pushed smoothly over the drain pipe with the least amount of effort from either side? And you would have to say it's this one, right? Which is your obtuse triangle. That's the best answer in that case. Justify why this type of triangle should be used for that ramp, making reference to the base angle, right? I would just say this: a greater top angle, right, comma, results in smaller base angles. Right, sorry, I was kind of a greater top angle results in smaller base angles. Like if you have, right, if you had like this being 150, let's say, then you have 30 degrees to be split. That would make these even smaller, right? So the smaller that top one is, the greater this one is, the smaller these ones become. And so essentially, right, the smaller these base angles are, the easier it is to push stuff over it. Smaller base angles require less force, right? And anything like that. I just don't want you to write like 2 or 3 words, right? Like just express yourself. If I can somehow make something out of that sentence or two, then you usually get the marks, right? So 1 and 1 so far, right? 1 and 1. And now we're going to do this last one, which you got plenty of examples of. So the first thing I'm going to do is address the fact that these two always add up to 180 degrees. It doesn't matter which side of the quadrilateral, but so if I wanted to go 180 and take away the 50, that would be 130 degrees. So you get 1 mark for that. On page 190, you should have that clearly. The 180 is always on the side there. And then the next is to find y, which essentially, if you think about it, it is this. It can also be drawn right here. I don't know if you saw that or not. But then you bring that out, right? You have your 90. This is 2.5. This is y essentially. And I'm just going to go 6, right? This whole thing minus 4. And I'm left with 2, right? If you have this, I would give you 1 mark already. If you took that right triangle and you put the 2 there, right? Those are significant concepts. So to find y, it's one of my legs. So I go hypotenuse squared minus the other leg squared. You square root that. You get 2.25 inside the root. You take the square root, that's 1.5 meters. Anybody use sine law? Sine law or cosine law? Yeah, that's okay. That's my fault. I just wasn't careful enough when I made up those numbers. 192, something like that? Yeah? You're okay. That's my fault, not your fault. That you should be able to use sine law and get the same answer. I think this angle is supposed to be like 39 or something for it to work out, something like that. So I fixed it already for next time that I get this one. All right, so this gives you another mark here, right, for getting that answer. So 1 mark for the angle, 1 mark for this, and 1 mark for finding the 1.5 meters. If you made a mistake here, this triangle, don't take away again here, even though I don't see how that would have worked for you. But anyways, this backside is 5. The backside is worth 5 total. The front, I said 10, right? So scratch the 13 at the top and just make this out of 15. Name and last name. Then get your booklets out to 195. $195. The work you've done, and then I will do polygons. Okay, we'll start with polygons. I'll give you a bunch of formulas, so make sure you write that down. All right, so this I assigned yesterday. So in this case, they wanted to know what y is, and because you can tell that the markings are telling you they're the same, it's just as easy as saying y is 2.4 feet, right? That's done. X and Z, I'm going to start with X, right? I know that these two here, these two angles add up to 180 degrees. I know that for a fact, right? So angle X is going to be 180 minus 118. And so angle X would give you 62, right? So you did a little bit of work to get that. And Z, angle Z is, these base angles are the same, so are the ones at the top, right? So I don't even need to do any calculation. I just need to state the fact that Z would have to be 62 degrees. So that's all that you needed to do there. Okay, and again, it all comes down to just knowing your reading markings and knowing your facts, right, about quadrilaterals. Then you have this one. This angle right here, what was it before? What did I give you there, 24 or something like that? If you use sine law, we're going to have a problem again. If you want it to work, this angle needs to be 59 if you use sine law. But I'm going to use Pythagorean theorem. So those of you using Pythagorean theorem, you'll be just fine. So let's find this first, right? So that angle, now you're gonna be upset at me, right? Because angle Y would be 180 minus this one right here. And to be fair to those of you that did this, it used to be 24, right? So let's just stick with that for now. 156 is the answer to Y, angle Y. Some of you cut this and got this angle, and you added 90 to that, but you still get the same thing, right? You should be. So there you go. Next is asking for X. So we're going to cut this right here. We know that this 6.2 comes over here, right? I'm actually going to draw this out. The 6.2 is here. This is X. This is a 90. I have to subtract these two. So 8.4 minus 4.7. That's 3.7. That goes there. Okay. So then you have everything you need to solve for X. And X here is the hypotenuse, right? I don't know if you want to label that clearly. So hypotenuse squared is going to be the square of the legs, right, added up. So x is going to be square root of that, which is 5213, which gives you 7.22 inches. And if you use sine law, it's something else, I know. So, my bad. I used to teach this before trig, so no student could check my work. But I switched it, and you'll see why a little later. So we have answered everything here. Next, we have the kite, right? And so for the kite, we are asked to solve for x, y, p, and z, right? Let's do the easy ones right there. So just side y is going to be 7 meters. Side z is going to be 18, right? We can actually write it down right next to it. So those would have been easy marks, right? Just read it off. No problem there. X and P, I'm going to do that in steps. So I'm going to take this triangle right here, cut it out. And this is X here for me, 7 there. And there's a little piece of information here. AC is 10. So from A to C is 10. I know that the shorter diagonal is split in half. So that makes this 5 and 5. So this little piece, right, was crucial for this to work out. Otherwise, you didn't have enough info, right? So this is 5 here. X is going to be my leg, right? So x squared, take the hypotenuse, subtract the other leg from it. So then if you square root that, you get square root of 24. X is equal to 4.990 meters. I'll just do that, right? So X was a little bit more work. Okay. Next, let's do P here. I will cut it out this way. P is right there. 5 is right there. This is 18. Again, this is the leg of this triangle. So P squared is hypotenuse squared minus the other leg squared. P is, that's 299 when you type that in. So P gives you 17.29 meters. And there's that. And I don't know if didn't leave a whole lot of room for myself here, but it's asking, let me use a highlighter here. This angle, ABD, where is that found? If you connect A, B, and D, it's asking for this angle right there. Okay? This angle is right there. We can call that M. Let's call it lowercase m right in there. And it's up to you what you want to do there. I think what I'm going to do, because technically that angle is right here, right? That angle is right there. And I have, I can use sine law there for that. Okay. So let me just cut it here. I'm going to use this like that. This is 7, and this is 5, and this is, I'm going to call this lowercase m there. So let me zoom into that so you don't have to squint too much. So here's sine law review. You need a pair, okay? So sine of 90 over 7 is equal to sine of m over 5. So you cross multiply right this way and divide. Sine of m is equal to 5 times sine of 90 divided by 7. Angle M is sine inverse of whatever this is. So I'm going to type that into my calculator. Sine of 90 is 1, right? So it's just 5 divided by 7, really. That's 0.714, and that keeps going. So angle M is 45.58. And I know you're going to be like, I did it differently, Mr. Dirksen. That's fine. We will be off maybe by a little bit, but not by a whole lot. Okay. There are many triangles in there that you could have used to find this out. And I had some students come up to me and try different ways. It all works out. Okay. So as long as you're not off by more than 0.01, you're okay. So this is probably, I would never ask you this many things at the same time, but it's just, you know, using the same diagram to come up with various things. It's a good challenge, right? All right. So what I'm going to do is I'm going to skip, like, instead of doing also doing the one that's on the next page that I made you copy, I'm going to skip that for now because we have a bunch of those that we worked through already. Let's go straight to page 203. 203 is where I want you to go. If you have a highlighter, have that ready as well. So we're going to talk about regular polygons, all right? This is the definition of a polygon. It's a closed figure formed by joining 3 or more segments and connecting them at their ends, basically, right? Not a surprise. These are the names and the number of sides that go with them. Now, I'm not going to say use your study sheet and fill in all of this. I think it uses up way too much space. But maybe, and I'm pretty confident that you know up to hexagon, you know how many sides the polygon will have. But maybe have heptagon to dodecagon on your study sheet, like how many sides it has. And watch this, add it to your notes. Number of sides is always in this unit, and we use the letter n for the number of sides. Okay. And here's a very important concept. If all sides of a polygon are equal and all angles are equal, it is called a regular polygon. If all sides are equal and all angles are equal, so both of them have to be a check mark, right? So sides need to be congruent, angles need to be congruent, right? That's basically what this is saying. For you to be able to call something regular, right, regular polygon, these two things must happen. So for example, let's just keep it very basic here to make the point. A square has all 4 sides equal and has all angles worth 90, right? So angles congruent, sides congruent. I'm trying to keep it as simple as possible. Check, check, therefore regular. Okay. What about a rectangle? If I gave you a rectangle, let's just make a quick sketch. It's longer than it is wide, so these two are the same. These two are the same. All four angles are 90. Okay? So you would say that angles are congruent, check, right? Sides, are they all the same? No, oh, nope, they're not, right? The sides are not the same. Therefore, this one is called irregular. So every once in a while it shows up in a certain way, like I ask you a question. So you just got to know when is it regular, when is it irregular. So an equilateral triangle would be regular, an isosceles would not be, right? Isosceles only has two sides being the same. So there we go. This is better than just giving you that. You know exactly what I'm talking about, right? All right, let's do this. I want to get to the polygon part. I don't know if you noticed that I'm... Okay, so this is where you need to wake up, right? So this is right after 203. I inserted this so it doesn't have a page number, but just look for it. There are 5 formulas, and this is how you... Oh, the good news is you don't have to have them on your study sheet, but I do want you to write them down, okay, on this piece of paper. So if you have your formula sheets, this is probably where you want your formula sheet. They're right here, S, I, E, C, D, right? There's the interior angle, which we call I. There's the exterior angle, which we call E. So psyched. Well, not really, but anyways, those are the five formulas that you're going to use in this section. Okay, and I will give them to you here. So the sum of all the interior angles is given by this formula. N minus 2 times 180 degrees. Oops, sorry, so crooked there. Let's try this again. N minus 2 times 180 degrees. And just somewhere you say where N is the number of sides. Okay? You need to know that all these formulas will have an N in it, so you need to know the number of sides of that polygon. If you wanted to know each interior angle, you start the same way, watch. It's the same start, except for you divide it by the number of sides. N minus 2 times 180 divided by N. And this is where the interior angle is found. If you look at a pentagon, it has 5 interior angles right here. So let's put a capital I on every single one of those vertices, right? We call them where they meet. 5 sides, 5 interior angles, right? 5 sides, you have 5 interior angles. The triangle has 1, 2, 3. No surprises there. So 3 interior angles right there. And those are just 2 examples, right? The central angle, just write down the formula, is 360 degrees divided by the number of sides. It's a very simple one. But you need to know where to find the central. Think of center. Find the center of that shape, okay? And then just travel out to one of the corners. Come back to the center, travel to the other corner right here. So you make a pizza slice. And that angle right there is called the central angle. How many central angles are there? Watch this. I'm just going to completely cut out this pizza into slices, right? There are actually, this one has 6 sides, 6 central angles, right? So it is like that with everything. There's the number of sides equals the number of angles that you will have. Okay, let's do one more here, just one. If this is the center, just go to one corner, go to the other corner. That's the central angle, so we label that with letter C normally. Okay. The exterior angle is exactly the same. It's 360 degrees divided by n. And you're like, aren't they exactly the same? Yes, they are. These two are exactly the same. But where they're found is different. And I'm going to ask you to label this. You can bet on it. Because I want to know where would the exterior angle be. So watch what I'm going to do. For the triangle, for example, if I ask you label one exterior angle, find one side, travel along it, and then just keep going straight, like instead of turning. So we travel along and just keep going straight, make a dashed line. That right there is the exterior angle. Right? And keep your journey. Let's now go down this side here. So we travel along it. And then as if you're going on a straight line, same pattern that you were traveling on already. That's your exterior angle right there. And there's one more. Travel to the other side. It's right there. Okay. 3 sides, 3 exterior angles. I don't know if you see the pattern. Let's say you have a 5-sided, a pentagon. You do the same thing. Right here, that's your exterior angle right there. Let's keep going. There's one right here. One right there. One right there. And one right there. Okay, so there are 5 exterior angles all along. It's like a water wheel. Okay. The number of diagonals, n times n minus 3 divided by 2. Can we add number of diagonals that can be drawn? Okay. It's the number of diagonals that you would be able to draw on that particular polygon. That's how you would find out. Okay. And so here we go. I'm going to use different colors. So diagonals, this would be 1, 2. Use a blue here. 3, 4. And there's one more. If you don't see it, it's right here. It connects there. So this one would have 5 diagonals. However, if you have more sides, you can have like 20, 30, 40, maybe even 100 diagonals. You don't want to draw them to figure out how many there are. So you use this formula instead. Okay? So let's do some math here. First thing you want to look at every single time is number of sides. 1, 2, 3, 4, 5. There's 5 sides. Okay? Before you calculate anything, figure out how many sides does this thing have. And it's asking us to calculate the interior, the exterior, the central of the following, and then label them all on the polygon using the letters I, C, and E. So let's calculate them first. The interior angle is found by going n minus, I will write out n minus 2 times 180 over n, right? So I is equal to, how many sides are there? There are 5. So you got to go 5 minus 2 times 180 divided by 5. So I is really 3 times 180 divided by 5. And if you type that in, you get 108 degrees. That's your interior angle. Okay. Then cut it here. Let's do our exterior next. Exterior is 360 divided by n. That's the formula. So we will go 360 divided by, we have 5 sides. And that, if you type that in, you get 72 degrees. What do these two add up to? 180, right? They're always going to be 180. So I'm gonna add a little note here. E plus I is always going to be equal to 180. Okay. The exterior and interior angle will always add up to 180. I will show you that in a bit. One more thing. The central angle. Central angle is exactly the same. So I'm not even going to write down the formula. I'm just going to say that it's 72 degrees. There it is. And if you want easy marks, you just got to know where they are. So I'm going to use red for I, label it. I'm going to go down here. You just have to label one of them, and that would be one of them. Just go to a corner. I'm going to use a blue pen to find the exterior, and I'm going to do it right next to it. Travel down the base here, and just keep going straight, right? That right there is the exterior angle. Can you see that they would be equal to 180? I hope you do, right? The central angle, find the center, and then just make your pizza slice. And it's the angle that those two cuts form that gives you the central angle. And let's do this here real quick. They always add up to 180 because they are along a straight line. They're supplementary. Right. I didn't do the number of diagonals, but you just basically use the formula and plug in, right? 5 times 5 minus 3, right, which is 2. And you divide that by 2 to get that. All right. I want you to practice this right away with these two right here. And you gotta be careful with your spacing. Okay, so I will do this. Calculate I, C, E, and D. right, for both of these. Don't do number 5 just yet. Just do whatever I just did, the interior, the central, the exterior, and the number of diagonals for these two shapes. And label the interior, the central, and the exterior, okay? So go ahead and do that. Make